Hello, my name is Ondrej Picha. I'm Applications Engineer in onsemi. Today I would like to introduce you our double pulse tester system for discrete components which we recently introduced. The purpose of the tester is that the user can rapidly test and verify switching losses over different discrete components and compare the losses also between different packages. The tester contains of a main board which is consisted of high voltage DC ring, gate driver stage, current measurement and a load inductor. Then the tester comes with a daughter card system, and those daughter cards are pre-assembled with onsemi components. Then those daughter cards are meant to be inserted into the system, and then user can connect the oscilloscope, high voltage source, signal generator, and measure the switching losses. Now I would like to explain extension boards which are available as an addition to the main board. First is a daughter card set available for the different and variety of packages. TO247, TO247 4 lead, SMD BPAC package, D2 PAC 7 lead, TOLL package, and SMD 8x8. The boards come without the components assembled, and the purpose is that the user can solder and test and compare the devices which come with the tester with the different devices, such as with the different RDS on or devices coming from a different vendor. If user wants to measure in an elevated temperature, there is another extension board which is consisting of the control board and a hot plate. The hot plate can be then screwed attached to the daughter card. Then another feature of the board is that it contains a double pulse generator. Then the signal cable can be attached to the main board, and system can operate as a standalone without using a signal generator. Now I would like to explain the basic operation of the double pulse tester. First, I prepared the main board. On the main board I connected the daughter card with D2 PAC 7 lead. On the main board I also connected the gate resistance of 10 ohms. Then on the daughter card I screwed the hot plate. For a signal generation I'm using the double pulse generator control board connected through this SMA cable. Then for oscilloscope sensing I'm using current probe attached here to the main board to sense the drain current. For the VDS voltage I'm using a high voltage differential probe connected directly on the daughter card. For the VGS voltage I'm using passive oscilloscope probe also connected directly to the daughter card. The system is going to be operated at high voltage, therefore it's always recommended to use a protective safety cover. Let's turn the high voltage source on. Set the pulse width on the control board and push start button to generate the pulse. After some delay time, the pulse is generated. Then on the oscilloscope we can see the blue curve is the gate voltage, the green curve is the drain current, and the magenta is the drain source voltage. Then switching losses can be extracted by using oscilloscope math functions and calculating the area of the power.